In this video, I'll just go over some of the Taylor, or really Maclaurin series, that we're going to acquaint ourselves with in class. And remember, for us, a Maclaurin series, this is a Taylor series centered at 0. So in other words, our A is equal to 0 for Maclaurin series. So we're always evaluating those functions' derivatives at 0, and we have x minus 0 raised to power. So we just have x to powers. So some of the series that you'll see come up here are the exponential. And the Taylor series for the exponential is the series from n equals 0 to infinity of x raised to some power all over n factorial. So again, this is a Maclaurin series because we see x minus 0 raised to powers, or we just have that x raised to a power itself. So if we write out the first couple terms of this series, this is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on and so forth. Some of the other functions that we'll see Taylor series or Maclaurin series of are things like sine and cosine. The Taylor series for sine is the series from n equals 0 to infinity of minus 1 raised to the power of n. So we have this flip-flop of signs, or alternation in sign, plus minus, times x raised to the power of 2n plus 1, all divided by 2n plus 1 factorial. So the first couple terms of the sine series are x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on and so forth. And what I want us to recognize for sine is sine really has all the odd powers. We have an odd number, a 2n plus 1 in that factorial in the denominator. And in that exponent, we have x raised to the power of 2n plus 1, again, another odd number. And the reason I bring that up is, well, cosine is going to have the even cases. So our Taylor series or Maclaurin series for cosine is the infinite series n equals 0 to infinity of minus 1 to the n. So cosine also has the alternation in sign, x raised to the power of 2n, all divided by 2n factorial. And the first couple terms of the cosine series look like 1 minus x squared over 2 factorials plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. So cosine has all of those even terms. Again, that's coming from the fact that we have this even number in the denominator, a 2n even number factorial in the denominator, and we're also raising x to an even power. 2 times any number will always be even. So those are the 3 kind of popular Maclaurin-Taylor series, but we actually already know another Taylor-Maclaurin series for that matter. This is our friend 1 over 1 minus x, which we actually were able to derive through kind of a geometric series reasoning. But it turns out that its power series representation as a Taylor series is the same exact thing. So remember, for this series, this was just x raised to the power of n. And in terms of this function, or the Taylor series, if we just write out the first couple terms, it's just 1 plus x squared plus x cubed, and so on and so forth. So these are some of the Taylor series for us really to memorize, get to know, get to love, because we're going to be using these to find other Taylor series. And what I mean by that is, for example, let's take our friend, the exponential function here, and let's ask ourselves, what if I want to find a Taylor series representation or Maclaurin series centered at x equals 0, not of e to the x, but of e to the minus x squared. And this is going to be where we use that whole kind of stenciling idea or composition of functions idea we've already used for power series. So basically what we can view this as is, again, e raised to something. And if we compare that with our original Taylor series for e, anywhere we have that x, we're just going to replace it with whatever is inside of those parentheses. So let me just grab our Taylor series for the exponential and bring it down here with us. So we have the Taylor series for this exponential. And basically what we're able to do then is say, you know what, if I'm raising e to whatever those parentheses are, the way I can really envision this is e to any power is equal to, well, the Taylor series, Maclaurin series of whatever I'm putting in those parentheses raised to the nth power and divided by n factorial. So the fact of what we're going to do basically is inside of those parentheses, we're going to put in minus x squared. So for example, we have e raised to the minus x squared. So inside of those blue parentheses, we are really just putting minus x squareds. Right, so putting those minus x squareds in that blue parenthesis, that actually gives us the Maclaurin series. So this thing on the right-hand side is actually the Maclaurin series for that function. So once we know some of these Taylor series, Maclaurin series, we can get Taylor series and Maclaurin series for similar functions based on them in a rather straightforward manner. And just to practice a little bit of algebra here, let's just do a little simplification of this series. So we have all of that product of -1 x squared raised to the power of n. So since they're all raised to the same power, if we wanted to, we could break those apart into individual pieces. So we could rewrite this series as well, a -1 raised to the power of n, and then x raised to the 2n power. And that's all divided by n factorial. So that is our Taylor series for e to the minus x squared. And we can do this type of stenciling or composition of functions to help give us Taylor series, Maclaurin series for other functions based on the ones that we have already.